right, next video. This one is going to be on ratios and proportions. We're going to start with ratios. And a ratio is just simply another way of indicating a relationship between two numbers. And it always indicates division. The numerator is the first number that's going to be listed. So let's take an example. Again, you should be looking at your ratios instruction sheet, all right, what would have been considered a handout in regular face-to-face class. And I'm right on that first page. Example number 1 says 3/4 written as a ratio. So we said a ratio is a way to represent a fraction. It indicates division, and the numerator is the first number listed. So 3/4 written as a ratio. Let's write it this way because I think it's easier to see numerator, denominator, okay? The numerator is the first number listed. So 3, and then what we do is we use a colon here. All right, 2 dots. And then the second number is your denominator. This is read 3:4, all right? Right here, that colon is 2. That's literally how that's translated. 3:4. All right, so that's the first one. The second example on your page says 7. How is 7 written as a ratio? Well, first of all, you have to have 7 written as a fraction. And we know that any number over itself can be written as a fraction. You just put 1. So the ratio of this, start with your numerator. Numerator is the top number. 7, put your colon in, is 2, denominator 1. And it's read 7:1. This is really, really simple stuff. I know you're probably thinking this should have come before everything else, but in the hierarchy of orders, you have to have all the fractions, the decimals, and the percents before you can get to this. All right, so ratios. The first section on your paper, actually the only section on your paper, says changing a proper fraction to a ratio reduced to lowest terms. And the first thing you need to do, let's look at example number 1. It gives you 4/12. Okay? Number 1, reduce the fraction to its lowest terms. That's important. You do have to do this here first. So you have to see if you can make this smaller. Again, if you're not someone who can do this real easily and just say 4 goes into 4 once, 4 goes into 12 3 times, do it by smaller numbers. Look at them and see if you can divide it by 2. You can say 4 divided by 2 is 2. 12 divided by 2 is 6. Then when you look at 2/6, you can say to yourself, okay, 2 goes into 2 once, and 2 goes into 6 3 times. Now you have 1/3. You can't make that any smaller. Now you are at your lowest terms. So whether you did it this way or whether you say automatically, you look at that and say, oh, I know that 4 goes into 4 once and 4 goes into 12 3 times, and now I have 1/3. Doesn't matter, you still came out to the same number eventually. Now you have your lowest terms, so you're going to take the first number, your numerator is going to be your first number, 1. Then you put your colon, is 2, your bottom number, 3. And that is it. That's simply it. It is very, very easy to do. Your ratio is 1:3, if you were to say that out loud. So let's do a second ratio problem. I'm going to erase this. Okay, and this is not on your paper, but I'm just picking it. Let's do 310 over 1,000. Okay, we have to make a ratio out of that. All right, let me just point out to you, doing this, because we said, oh, you just take the numerator over the denominator. Put the numerator first, put your colon, and then the denominator. That would be wrong on an exam because you have not reduced it to lowest terms yet, okay? If you looked at it here and you did that first and then you said, oh, wait a minute, wait, I can reduce that, and then you somehow got to the lowest terms, then I would accept it. But if you left it this way, you cannot just take it and write it and say, I'm done with it. You need to do the lowest terms. So let's get rid of this for now. Some people, you should be able to do this. I can give you a very easy tidbit of information to remember. If a number ends in 0, it's divisible by 10, okay? So you can say 310 divided by 10. If you don't know that, you can use your calculator. However, you can also just cross off equal amounts of zeros. In other words, if you're going to cross off 1 0 here, you can cross off 1 0 there. Okay? And I promise you, if you take your calculator and do 310 divided by 10, because you're crossing off 1 0, you're going to come out to 31. And if you do 1,000 divided by 10, you're going to come up with 100. Okay? So you now have 31 over 100. That can't be reduced because 31, nothing goes into 31. Now, all you have to do is take your numerator, put it first, put your colon, and then your denominator goes second. This is the answer I would be looking for on an exam. 31 is to 100. That's your ratio. Okay? That's all I have to say about ratios. I told you there's not very much here. But they're important because you have to know ratios in order to do proportions. All right, proportions. Now look at your third instruction sheet on proportions. And halfway down the page, you're going to see that a proportion consists of two ratios of equal value. All right, I'm going to write two ratios right now. I'll tell you what this is in a minute. Here's one ratio, 2 is to 3. Here's a second ratio, 4 is to 6. So they're both equal value. I'm going to show you exactly what that means. And they're connected by a double colon, so 2 colons side by side, which symbolizes the word as. Okay? The 1 colon means is to. The double colon, as. Here's another, is to. So if I were to read this, I would read it as 2 is to 3, as 4 is to 6. All right, what does that mean? It means that the two ratios equal each other. And we're going to show you how to do that. The first thing I want to show you, though, is what's next on the paper. You have to know what each of the terms are called. So the two outer numbers, 2 and 6, the ends of the ratios, those are called the extremes. They both start with E, okay? The ends are the extremes. The two middle numbers are called the means. 2 M's. 2 M's, 2 E's. All right? What that means is as we get going, let me rewrite it here. The means, which are the middle, should equal the extremes. So the two outer numbers should equal the two middle numbers. Now this is such a simple problem that you can see it already does. 3 times 4 equals 12. 2 times 6 equals 12. That gives you this proportion as being accurate. If you didn't come up with the same numbers for the extremes and the means, then it would be wrong. Okay? That's pretty much the whole thing there. So we kind of did that already. But I'm saying this in our minds. We pretty much, all of us already know that 3 times 4 is 12 and 2 times 6 is 12. But now let's do it out saying you didn't know that. Or actually, we're going to do what the proportion is typically used as. It's used as something where one of these numbers is actually missing. All right? So if you continue looking at that instruction sheet, it says solving a simple proportion problem. And it gives you the same problem, but with one number missing. And if the number's missing, we call it X, all right? So solving a simple proportion problem, and it gives you the 4 steps to it. The first one says to multiply the extremes. The extremes are your ends. The second says multiply the means. That's your middle. Then place the product, I'm on number 3, place the product that includes the X. That means over here, and it may not, X could be anywhere here. It doesn't matter, you can change it X to different spots. In fact, I'll show you that in a minute. But wherever X is, you want it to be on the left side of your equation, okay? So let's look at it. X is on the outside, so 2 times X is 2X. Remember, they're going to equal each other. Now go to your means. You did the extremes, the ends. Now we're going to do the middles. 2X should equal 3 times 4. 2X equals 3 times 4 is 12. Now we want X. We want to know what X is, not 2X, 1X. So in order to get X over here, we have to divide by whatever number's in front of it. So we're going to divide both sides by 2. So 2 divided by 2 gives you 1X. And 12 divided by 2 gives you 6. That then gets plugged in for the top number, and we already know that to be true. We did it before, but that's all right. Let's do it again. 2 is to 3 as 4 is to 6. And then to double check it, we can always say 3 times 4, your means, equals 12. Now multiply your extremes. 2 times 6 equals 12 also. As long as they're the same, you know your answer is correct. So this is a way to double check your answer and make sure you are correct. Okay? Let's see. Let's do another example. Actually, before I do another example, let's move the X so you can see that X can be anywhere, and we'll use the same problem, okay? So this is not on your handout, on your instruction sheet, but let's just do it anyway. Let's put X over here. Okay? All right, let's see if this still works out correctly. All right, so it says the first thing, multiply the extremes. It doesn't matter. What matters is the very, very important thing is that X is always on your left. Keep X on your left. So if X is one of the middle terms, multiply those first. 4X times 4 is 4X. Keep that on your left side. Now multiply your extremes. 2 times 6. 4X equals 2 times 6 is 12. Now, if I want to get X over here, plain old X, I have to divide by 4, okay, because 4 over 4 is 1. So I'm going to divide by 4 over here. I also have to divide by 4 over here. X equals 12 divided by 4 is 3. So, X is 3. And you see that it worked out exactly the same. Didn't matter where I had the X, okay? You'll get a different number for the X, but it always works out to the same equation. 2 is to 3 as 4 is to 6. All right, let's do one more. This one's not in your handout, so I'll just put it up here. I want you to be sure you understand. All right, let's do as an example. Let's put X as the first number. X is to 8 as 10 is to 20. All right. Your means, the two middle numbers, always equal the extremes. So you can do that just to kind of remind yourself. Make little arrows. 8, the two middle ones should equal your two outer ones. All right, x, you want x on the left all the time. So 20 times x is 20x. Whoops, let's make that a little better. 20x equals 8 times 10. 20x equals 8 times 10 is 80. Now we want 1x over here. That means in order to get rid of all these numbers, we have to divide by the same number. If you're going to divide by 20 on one side, you got to divide by the same number on the other side. So 1x, 80 divided by 20. Again, if you're not, really quick with this, you can use the calculator because you're not going to be able to figure out ratios and proportions with calculators that way, but you can use them to help you get numbers. 80 divided by 20 is 4. And that would be your answer. The way that you would check it, plug 4 in over here. 4 is to 8 as 10 is to 20. Multiply your means and see if it equals your extremes. 8 times 10 is 80. 4 times 20 is also 80. That adds up. All right? So that's how you do proportions. And proportions are pretty simple. Proportions, this is what we need in order to start doing what we're going to be doing in the next section next week, which is equivalence. Now we're going to start talking about the metric system and being able to talk about milligrams and grams and be able to go from one to the other. You'll have exercises that are all proportions. And just to kind of give you an example, what's coming up, it would look like this. It would say x is to 8 milligrams as 10 grams is to 20 milligrams. Something like that. You're going to have your metric measurements included in these types of proportions. And this is what we're heading for, because if you ever have to convert milligrams to grams or something like that, you need to know how to do this. So that's our whole reasoning for learning proportions. All right, so that's next week. Let's get rid of it. For this week, you're just learning the proportions. All right, as always, if you have any questions, please email me.